So let's get started. The midpoint of a line segment is the ordered pair 8, 5. And so you definitely needed to read that first line to realize they gave you the midpoint. They gave you the midpoint. So when they give you the midpoint, that means you're looking for an endpoint. So you should have used EME, and this was in advisory this week. We use EME when we're looking for an endpoint. So that is the big bad batric structure for that. And it's necessary that my midpoint go in the middle here. So the midpoint is 8, 5. That's very important, okay? They give us one of the endpoints is 13, 6. It doesn't matter where it goes, but I always put it at the top because when I'm trying to figure out my pattern, it's easier just to look straight down. Okay, so my pattern is to get from 6 to 5. What do I do? Minus. Subtract 1. So y'all, I'm going to do it again. 5 minus 1 is 4. Okay, my pattern to get from 13 to 8.
Minus 5.
Subtract 5. So I'm going to subtract 5 again, and I get 3. A was the correct answer. How'd we do? Okay. All right. Now it says, what is the midpoint? So they are asking you for the midpoint, and they are giving you the endpoints. Okay. That's a different setup. Okay. Now, y'all, this setup would work. It's just harder to figure it out. Okay. So that's when I do this for the big bad batric structure. We know midpoint is a point, so that's why we've got an ordered pair here. Okay, the setup is divide by 2, and we're going to add two things together on the top. Well, the first part of an ordered pair is the x coordinate, so I need my x coordinates for the first part, 8 and 3. So they go here. The second part of an ordered pair are the y coordinates, so I need the y coordinates, 12 and 5. They go here. And now it's just a matter of simplifying. When I add the top, I get 11, so I have 11 over 2. When I add the top here, I get 17, so I have 17 over 2. If you look at your answers, they're not in fraction form, they're in decimal form. So we have to change these. 11 over 2 is the same thing as what in a decimal? 5.5. How about 17 over 2? 8.5. The correct answer was C. How'd we do? Good. All right. Okay, evaluating functions. They're giving us two functions. They're asking us what is g of 2 added to h of 4. Okay, so the first thing I need to do is find g of 2. It sounds like negative 10 blank minus 8. Negative 10 blank minus 8. What goes in the blank? 2. So when I multiply here, that's negative 20. And negative 20 minus 8 is negative 28. Now I've got to do h of 4. Okay, what does h of 4 sound like? 8 blank plus 2. 8 blank plus 2. What goes in the blank? 4. 8 times 4 is 32. Add 2, you get 34. They are asking us to add those together. So we've got negative 28 added to 34. The signs are different, so I'm actually subtracting. Okay? And I get a positive 6. How'd we do there? Anybody got a question so far? Anybody got a question? Okay. All right. we've got to find a key phrase here on what they want, because y'all, in a table you can find all kinds of things. In a table we can find slope, we can find x-intercept, we can find y-intercept. Okay, in an equation we can find slope, we can find y-intercept, we can find x-intercept. So what are they asking us to do? Well, if you look, it says what is the slope of the function with the larger slope. So we've got two functions. We've got f of x and g of x. Well, f of x, it's real easy to find the slope because it's in mx plus b form. So your slope there is 1/4. Question on that? Okay, how do we find the slope in a table? Yep, big bad bachick structure and doo-doo. So I'm going to set up the BBBS. I'm just going to pick the first two, but we know with something linear, it doesn't matter which two you pick. So, -9, -10, down, up. When I simplify the top, I get -2. When I simplify the bottom, I get -3. A negative divided by a negative is a positive. Okay? So, I've got a slope of 1/4 and a slope of 2/3. Y'all, if you don't know which one is bigger, if you put it in the calculator and press enter, if you put 1/4 in, you're going to get 0.25. If you put 2/3 in, you're going to get 0.66 repeating. So which one is bigger, the 1/4 or the 2/3? The 2/3 is the bigger one. The correct answer was B. How'd we do there? Okay. Any question? Y'all, you're looking for the key phrase. They could easily say something about the y-intercept. Okay? All right. Last one. We're given a linear graph and asked to match it. And asked to match it to the equations. Y'all, the equations are in standard form, which is tougher. The best way to do it is going to be x and y intercepts. Okay, so in this graph, my x-intercept is what?
+6.
+6. My y-intercept is what? -4. So I am going to cover up until I get an x-intercept of +6 and a y-intercept of -4. Okay, so first thing I'm going to do is cover up my y. And when I divide, what is 24 divided by -4? Waiting. 24 divided by -4. It is -6. If I cover up my x and divide, what is my y-intercept? It is 4. If I look here, not going to work. My x-intercepts are not correct. They don't match. So let's go to the second one. Be careful, because here, see, they switch the x and y on you. So I'm going to cover up here for my x-intercept. What's my x-intercept? 6. I'm going to cover up here. What's my y-intercept? -4. Take a look. They match. B is the correct equation that matches the graph. Question there. So, basically what I want to do is show you where we're going. Okay? If you remember, the last page of your notebook, we were converting forms. Okay? So basically with the linear, in your notebook, under linear, we went from standard form to slope-intercept form, then slope-intercept form to standard form, then point-slope form to slope-intercept form. We were changing forms. And then we wrote that under exponential, there was nothing to convert. Well, y'all, where we're headed is for quadratic. Okay, so if you look with quadratic, we've been dealing with factored form, standard form. Okay, you guys know how to go from factored form to standard form. Y'all knew it before I said it. You said we're going to do a 2x2 box and multiply this. Okay, well, what we're going to do is we're going to go backwards. I'm going to show you how to get from standard form to factored form. To get from here to here, we do 2x2 boxes. To get from here to here, we actually have to factor. Okay, so that's where we're headed. That's what we're doing today. Okay, here's another example. Okay, you guys know that if I was to give you this and tell you to multiply, you would distribute and get 12x squared. You would distribute and get 18x. Well, this is factored form. That's standard form. You guys know how to get from here to here. I'm going to show you how to get back today. I'm going to show you how to go this way today. Okay? These guys, okay, you've been given this, and you're like, that's a 2x2 box, and you get this. I'm going to show you how to start here and get to here. And it's a pretty big deal. It is a major part of Math 2, being able to factor these, okay? So it's a pretty big deal for next year, okay? All right, so with that in mind, okay, we've got to talk about factors, okay? So that's why you got this sheet, and when we get done, maybe tomorrow or something, we'll figure out a place to glue this down. I'm not sure yet where I want it to go, okay? So notice factoring. The title says factoring, using the greatest common factor method. So basically, we are finding factors. We are finding factors. Okay. Factors are expressions that multiply together. Factors multiply together to give us our original expression. So they're giving you examples. 2x and 3x are factors. If I multiply those together, I get 6x squared. Okay? The greatest common factor is the largest number that divides evenly into the original numbers. It's the largest number that divides evenly into the original numbers. So we have 12 and 16. The greatest common factor would be what?
16.
The biggest number that divides into both of these evenly. The biggest number that divides into both of these.
4.
4 goes into 12, 4 goes into 16. It is the biggest number that goes into both of them. So that's what we mean when we're pulling out a greatest common factor. Okay, that's for numbers. Okay, well, y'all, you can do greatest common factors with variables. To find the greatest common factor of a monomial, we're going to find the greatest common factor of the coefficients. And remember, the coefficients are numbers. We just did one of those. And notice they're bringing variables into this, y'all. Letters. And any common variable, and keyword here is common, with the smallest exponent. Y'all, the smallest exponent is going to be the common factor. The smallest exponent is going to be the common factor. Okay, so notice, y'all, we've got coefficients, 15 and 20, and now we have variables. We've got x's, so let's do one at a time. 15 and 20. 15 and 20. What is the largest number that will go into both of those? 15 and 20.
5.
5 is the largest number that goes into both of those. Okay, now, both of these have an x in them. The greatest common factor is the smallest power. I'm going to say again, the greatest common factor is the smallest power. And let me show you why. Y'all, x to the third is x times x times x. That's x to the third. Okay, x to the fifth is x times x times x times x times x. Y'all might want to write this down. Okay, so y'all, what do they have in common? Look at this. Well, I'll wait. People are right. Okay, so y'all look. What do they have in common? This has 3 x's multiplied together, and this has 3 x's multiplied together. That's what they have in common. Well, if I put it back together, I get x to the third. If I put it back together, I get x to the third. So notice again, I've got x to the third and x to the fifth. The greatest common factor between those is x to the smallest power that's there. The smallest power that's there. So the greatest common factor for these two monomials is 5x to the third. That's what we're going to be practicing a little bit today. Okay? Okay. All right, so notice they're giving us a problem to factor. Factor out the greatest common factor and go through the steps. Okay, so I've got 6x squared and I've got 18x to the fifth. I need the greatest common factor. Let's look at the coefficients first. 6 and 18. 6 and 18. Y'all gonna have to help me, folks. If I'm just gonna go through and tell it to you, I mean, you're not learning anything. 6 and 18. Okay, I heard 3, but there's a bigger one. It's 6. Y'all, 6 goes into 6 evenly, goes in there one time, and 6 goes into 18 3 times. So yes, 3 is a factor, but it is not the greatest common factor. The greatest one is 6. Okay, now both of these have an x in them. So what power goes on the x for a greatest common factor?
2.
X to the second power. That is correct. So for this expression, 6x squared is the greatest common factor. Okay, now, y'all, finding the greatest common factor doesn't factor this. We're not done. Okay? So basically, it tells you put the greatest common factor outside of a parenthesis. Now, y'all, I want you to do this in a special way. I want you to come to the bottom of the box here. And I want you to put 6x squared here, because that's my greatest common factor. And I want you to set up a big parenthesis. Not a little tiny one, a big parenthesis. Okay? Okay, and I just want to remind you where we're going. Take a look at this. Y'all, if I gave you this, you would distribute and get this. We are now looking at this and going backwards. Look what's going on. There's a greatest common factor out here, and I've got to fill in the parentheses. It's almost like I'm doing distribution in reverse. I'm doing distribution in reverse. Okay? So, I've got my 6x squared outside, and I've got to figure out how to fill in these parentheses so that if I went backwards, I would get the original expression. Well, y'all, there is a mathematical way to do that. If going one way we multiply, going the other way we divide. So notice, look what it says. Divide all terms by the greatest common factor. So this is what I want y'all to do up here. We're going to write the original expression, 6x squared plus 18x to the fifth. And we are going to divide each one of those terms by our greatest common factor. So look, divide by 6x squared, divide by 6x squared. That's what they mean by divide all the terms by the greatest common factor. Okay? Now, hopefully, there is a skill you've already learned that is kicking in right now. Y'all, you have learned how to divide monomials. You have learned how to divide monomials. What do we do with powers?
Subtract.
Subtract. What do we do with the coefficients? Divide. So y'all, you have the skill to do this. Now, this first one's weird. What happens to 6x squared on top and 6x squared on the bottom? And when it cancels out, y'all, it represents a number. What number does it represent when it cancels on top and bottom?
1.
It represents a 1. Y'all, if you've got two terms here, you've got to have two terms in parentheses. Do you see what I'm saying? You can't just leave it. That right there represents a 1. That's a 1. It's got to go in that spot. That is a term. I got to have a term here. Okay, now I've got a second term, so I got to have something here. So what is 18 divided by 6? 3. What did Justice say to do with the powers? Okay, so what goes in this is 3x. I subtract powers, and I get a 3. We just factored. Okay? How do I double check? Check this out. What is 6x squared times 1? Oh, there was your first term. Okay, check this out. What is 6x squared times 3x cubed? Well, I multiply 6 and 3 and get what? What do I do with the powers? So far, you've been able to go from here to here. I am now showing you how to go from here to here. Okay, you just factored. Okay? All right, let's do some more. Really need you guys paying attention, y'all, because for all of the factoring we're going to do in the next couple of days and next week, all the different factoring methods require you to be able to do a GCF. So please make sure if you're deciding to take a break right now, don't. Okay, don't. Okay, we've got two terms. Let's look at the coefficients first. 15 and 25. What is the greatest common factor that goes into 15 and 25? 5. Okay. I have y's in both of these. It's important. Y's got to be in both of them. Okay, so what power on the y is going to be the greatest common factor? 2. So 5y squared is my greatest common factor. Okay, I'm going to use that to write this expression in factored form. What does step number 2 tell me to do? The greatest common factor. So y'all, look what I'm going to do. I'm going to come right up underneath that first term, and I'm going to write 5y squared. I'm going to come right up underneath the second term, and I'm going to write 5y squared. Okay, now, let's get our setup going. Look what it says. Put the greatest common factor on the outside of the parenthesis and set up a parenthesis. So at the bottom, I'm going to put 5y squared outside my parenthesis, and I'm going to set up a nice big parenthesis so I'm not cramming stuff in the parentheses. Okay? Okay, now, I've got two terms. I should have two terms here. So let's divide. 15 divided by 5. 3. What do I do with my powers? So 3y's in the first slot. Okay? This is positive divided by positive, so I should already know a plus sign is going to go there. Okay? All right, 25 divided by 5. Okay. And what happens to y squared and y squared? Gone. Here's your factored form right here. Again, notice if you go backwards, 5y squared times 3y is 15y cubed. That's my first term. If I distribute here, 5y squared times 5 is 25y squared. Okay? Okay. All right, in number 2, I have 3 terms. We can still do a greatest common factor. So what I'm going to do here is I'm going to pause for a minute and see if you can find the greatest common factor of these 3. Start off with the 9 and the 3 and the 27. We're not worried about negatives. Start off with the 9 and the 3 and the 27. Don't yell it out. Think of what it would be. and then look at your variables. See if you can figure out what the greatest common factor is. All right, what do we think the greatest common factor is? It is 3, because 3 is the biggest number that goes into these. And you know what I do, folks? I always find the smallest coefficient and just see if it goes into everything. If it does, that's your greatest common factor. Okay? If it doesn't, you got to do some more thinking. Okay, and x to the first power, why? First of all, I've got x's in all of these. That's what in common means. Power of 3, power of 2, power of 1, so the smallest is power of 1. Okay? Okay, now I'm going to do my setup. I'm going to put my greatest common factor out here. I'm going to set up a big parenthesis. I'm going to make it a little bit bigger because I got 3 terms now. I got 1, 2, 3. Okay, what do I need to do up here to get ready to fill in? What do I need to do? Divide each one of these terms by the greatest common factor. So look what I'm doing. Okay? And now I'm going to pause and let you see if you can fill in these spots. Now, y'all, I'm going to go ahead and help you out here. Notice there's a minus sign and a plus sign. So look what I did. I created 3 spots. 1 spot, 2 spots, 3 spots. I'm going to pause for a minute, let you see if you can figure out what goes in the spots. You're dividing here. Okay, this first term, 9 divided by 3 is 3. When I subtract powers, that's an understood 1. I get x squared. 3x squared goes in the first slot. Here, when I divide, I get a 1. And then when I subtract powers, I get an x to the first power. So, y'all, that's nothing but an x. If you wrote 1x, that's fine. If you wrote 1x to the first power, that's fine. On a standardized test, it's going to look just like this. Okay? Last term. 27 divided by 3 is 9. What happens to the x's? They're gone. So, y'all, when the x's cancel, you don't put an x there. Okay? There's your factored form. There's your standard form. Factored form, standard form. Okay? All right. I'm going to pause. See if you can find the greatest common factor. Start with 7 and 49, then look at your x's, then look at your y's. You do all 3 separate. Okay, between 7 and 49, what's the greatest common factor?
7.
It is 7. Do I have x's in both terms?
Yep.
Yes. What's going to be the GCF for that?
7x1.
It's just going to be an x because the smallest power is a 1. Do I have y's in both terms? Got to have them in both. Okay, so what's my GCF for the y's? Y to the first power, because that's your froze. Okay, yeah, y to the first power. So, y'all, that's my GCF. So that goes on the outside. I'm going to set up a big parenthesis. I can go ahead and put a plus sign here to separate my 2 spots. Okay, so I'm going to let you guys finish. See if you can figure out what goes in those 2 spots. Okay, 7 divided by 7 is a 1. X's cancel. The only thing there should be a y to the first power. That's it. If you have 1 y, it's the same thing. 7's cancel, x's cancel, y to the first power is all that's left. Okay? Here, 49 divided by 7 is 7. Y's cancel. And when I subtract the powers on the x, I get an x to the first power. Folks, if they cancel, you do not put the y down here. It's gone. Okay? How'd y'all do there? Okay, again, we'll let y'all know what we're doing. Y'all, we are not solving anything. We are literally changing forms. That's all we're doing. This form is equivalent to this form. It's just two different forms. That's standard, that's factored. Okay? All right. I'm going to let you guys try to do this one all by yourself. And some of y'all have already done it. But I'm going to pause and let you do this one all by yourself. Got to find the greatest common factor first. Tucker, you're going to be real lost. Finding the greatest common factor. Y'all need to try this before I do it. All right, let's see how many people fell prey here. First of all, did you realize that 6 is the greatest common factor? There are no variables in common in all three of those. How many people wrote out some variables for the greatest common factor? Tell the truth. Okay. Y'all notice we have x's in the first term, x's in the second term. There is no x in the third term. So if you pulled an x out, you probably, when you got to divide and going, well, I can't do it. So you can't pull an x out, it's not in common. Now let's look at the y's. We've got y's in the third term, y's in the second term. We have no y's in the first term. We cannot pull a y out. The greatest common factor here is 6. Okay? So I pull out a 6. I set up a parenthesis. I'm going to bring down my plus and my minus. And I'm going to divide each term by 6. So here I get 2x to the 5th. Here I get 6x squared y. And here I get 3y cubed. Okay, we got time to try another one. Let me see if I can find a good one here. Hang on. Okay, y'all, let's do number 8. Let's do number 8. We're going to jump around and we'll do some more tomorrow. Let's do number 8. Okay, so first thing you're going to do is find the greatest common factor. Do you have x's in all three terms? Then an x, at least to the first power, is coming out. Do you have y's in all three terms? Okay, just throwing that out there. Everybody's got one card, right? Okay. Okay, let's see how we did. All right, so we were doing number 8. What'd y'all get for greatest common factor?
5x1.
5, x cubed, and x to the first. I got to pick the smallest power. Y, and y squared, got to pick the smallest power. It's 5xy. I'm going to go ahead and come down here, 5xy. I'm going to set up a big parenthesis. Bring down a minus sign and a plus sign to get my slot set up. And I'm going to divide each one of these by 5xy. Okay? All right, first term, 2x squared. That's all that should be in the first term. There should not be a y. Okay? Second term, 5's cancel. Y's cancel. When I subtract powers on the x, all I should have is an x squared. If you have 1x squared, it's the same thing. You should not have a y. Okay, last term, 25 divided by 5 is 5. X's cancel. When I subtract the powers, I get y to the first power. How many people got that right? All right. Okay. All right, tomorrow, when I ask you to pull this sheet out, I need for you to have it. Did y'all get that?
Yes.
Okay. All right.